Hello and welcome to this episode of my tutorial video series. The subject of this video is microeconomics and the topic is derivation of demand curve from the law of equimarginal utility. The law of equimarginal utility, as postulated by Marshall, states that when a consumer consumes multiple products, say n number of products, then the ratio of marginal utility of a commodity and its price will be equal to same for all the commodities, and that will be equal to the marginal utility of money. That is according to law of equimarginal utility. Law of equimarginal utility states that the consumer will be in equilibrium, that is, the consumer will maximize his satisfaction from consumption of n number of commodities when mu1 by p1 will be equal to mu2 by p2 will be equal to mu3 by p3 will be equal to mun by pn, which will be equal to mum. That means marginal utility of commodity 1 by price of 1 is equal to marginal utility of commodity 2 by price of 2 will be equal to commodity 3, commodity 4 until marginal utility of nth commodity divided by price of n commodity, which will be equal to marginal utility of money of the consumer. So we get a curve like this. These are all, say, mu1 by p1, mu2 by p2, and so on. Mun by pn will be equal to mum. These are the quantities of commodities the consumer is consuming and maximizing satisfaction by equating the ratios of marginal utilities and prices of the commodities with the marginal utility of money, right? And when the consumer is consuming only one commodity, in that case, what will happen? Say the consumer is consuming commodity X, then mu X by Px will be equal to mum. This is for multiple commodities, and this is for single commodity, one commodity. Right? So when the consumer is consuming only one commodity, then the consumer maximizes his satisfaction by consuming that many quantities where his mux by px becomes equal to his marginal utility of money. And so the graph becomes like this. This is mum, this is mux by px, in y-axis we measure marginal utility by price, and on x-axis we measure quantity. So the consumer is consuming, say, OQ units of the commodity and deriving marginal utility of this much from that commodity, which is equal to the marginal utility of money. So mux by px is equal to mum. This is what the law of equimarginal utility states. Now this video will focus on how the demand curve can be drawn from this law of equimarginal utility. In fact, law of equimarginal utility, the theory of indifference curve and demand theory, all are theories for analyzing consumers' behavior, and all the theories are interrelated. And specifically this topic, that is derivation of demand curve from the law of equimarginal utility, is at the juncture of utility analysis of consumers' behavior and demand theory of consumers' behavior. Right? Now, the law of demand states that quantity demanded for a commodity is inversely related with price of that commodity, ceteris paribus, that is, other things remaining same. That means when price of a commodity increases, quantity demanded for that commodity falls, and when price of a commodity falls, quantity demanded of that commodity increases. So quantity and price are inversely related to each other. That is the reason the demand curve is downward sloping. This is the demand curve. On x-axis we measure quantity, and on y-axis we measure price. So we get a point on demand curve where the price is, say, P1 and the consumer is consuming OQ units. And when price of the commodity falls to P2, we get this point on the demand curve, DD dashed. This is P2. Then quantity demanded increases from OQ1 to OQ2. This is law of demand. Ceteris paribus assumptions are other factors, those influence quantity demanded, remain constant. Only changes in price are considered in law of demand. Demand is a function of price, income, tastes, preferences, and many other factors. Correct? Demand is a function of many factors. And among those factors, P and Y are the strongest factors that influence demand. That is to say, the price of a commodity and income of the consumer are the strongest factors that influence quantity demanded for a commodity. Now, in case of law of demand, we are considering the relationship between quantity and price, Q and P. So here quantity demanded is a function of price. So here Q is FP. Other things, that means income of the consumer, tastes, preferences, and other things remaining constant. With these ceteris paribus assumptions, the law of demand states that when price increases, quantity demanded falls, and when price falls, quantity demanded increases. Now, the law of equimarginal utility states, law of that mu x by px equals to mu m. This equality provides maximum satisfaction to the consumer. Correct? Now we shall link this and this by deriving the demand curve from the law of equimarginal utility. Let us see how can this be done. I am erasing this part, okay? Now I am drawing two diagrams. Basically, this is one single diagram having two parts. Top part and the bottom part. On this top part we measure quantity on x-axis and marginal utility of x divided by price of x on the y-axis. And in the bottom part of the figure, on x-axis we measure quantity and on y-axis we measure price. Right? Now mu x by px mu x by px will fall if mu x falls. Mu x by px will fall if mu x falls. As we are considering px as constant, so if px remains constant, that is price of x remains constant, marginal utility will fall, and as a result the value of this fraction will fall, will come down. If numerator falls, denominator remaining fixed, then the whole value comes down. So as we have seen in marginal utility curve that it is downward sloping, this is mu. On x-axis we measure quantity, on y-axis we measure marginal utility. Then as the consumer consumes more of a commodity, the marginal utility comes down. That is why the marginal utility curve is downward sloping from left to right. If px, that is price of x, remains constant, then mu x by px will also fall. Suppose price of x is px1. So this is mu x by px1 line. The consumer is consuming. This is MUM. This is MUM. So the consumer is consuming OQ1 units of the commodity. Correct? Now suppose price of x falls to px2. Price of x falls to px2, from px1 to px2. As price of x falls from px1 to px2, money income of the consumer and other things remaining constant, the consumer's purchasing power will increase, and with the increased purchasing power the consumer will try to maximize his satisfaction or to increase his satisfaction, and as a result the consumer will purchase more of the commodity, that is the consumer will purchase more of x, and as the consumer consumes more of x, mu x comes down. Correct? So mu x will fall. If the consumer purchases more. So the new price line, the new MUX BX line will be like this. This is MUX by PX2. Now this will be parallel. Why? Because as price of X is falling, the consumer is purchasing more of X. As a result, MUX will fall. At the same time, since price itself is falling, so ultimately MUX by PX2 will be equal to marginal utility of money. That is, this MUX by PX1 and MUX by PX2 will be equal, because when price of X falls from PX1 to PX2, the consumer purchases more of X. At the same time, price of X falls, so MUX falls and price of X falls. As a result, MUX by PX2 again remains at equal to MUM, marginal utility of money. So here the consumer is consuming OQ2 units. So as price has fallen from PX1 per unit to PX2 per unit, consumption of the consumer has increased from OQ1 to OQ2. Again, suppose price of X falls to PX3, from PX2 to PX3. As a result, the new MUX by PX line will be this one. That is, this will be the MUX by PX3 line. Again, the consumer will be in equilibrium by consuming, say, OQ3 units. Because by consuming OQ3 units, the consumer's MUX by PX3 is equal to MUM, marginal utility of money. Right? Now we know the values of PX1, PX2 and PX3. We know the values of prices of X as it is going down from PX1 to PX3, and we know the values of quantities consumed by the consumer at the respective prices. That is what we require in constructing the demand curve, because demand curve shows the different coordinates of prices and quantities as price of a commodity changes, and as a result quantity demanded for it changes. So these two things, that is PX1, PX2, PX3 on one hand and Q1, Q2 and Q3 on the other hand, we can draw the demand curve out here. So when price is PX1, the consumer is consuming OQ1 units. So this is OQ1 when price is PX1. We know the value of price, say this is PX1. When price of X falls from PX1 to PX2, the consumer is consuming OQ2 units. So this is Q2. And we know the price of X after fall in the price, that is PX2, which will be less than PX1. Let this is PX2. Correct? This is Px1 and this is Px2. This is Q1 and Q2. Q1 and Q2 we have plotted from this part of this diagram, and the values of Px1, Px2 and Px3 are known to us. Again, as price falls from Px2 to Px3, the consumer consumes OQ3 units. This is Q3, and the price has fallen to Px3. Let these be Px3. So we get these 3 points. Say this is point A, this is point B, and this is point C. Correct? Now the line joining these 3 points is the demand curve. The line joining these 3 points is the demand curve DD dashed. Correct? So this is the way we can derive the demand curve from the law of equimarginal utility. The law of equimarginal utility states that the consumer is in equilibrium, that is, the consumer is maximizing his satisfaction when the ratio of marginal utility of a commodity and its price is equal to marginal utility of money for the consumer. This marginal utility of money depends upon the money income of the consumer, that is the disposable income of the consumer. The consumer is in equilibrium when MUX by PX is equal to MUM. So here we have drawn 3 MUX by PX lines for 3 levels of prices of commodity X, that is Px1, Px2 and Px3. The price is falling from Px1 to Px2 and then to Px3, and the consumer is again and again equating MUX by Px with MUM to derive maximum satisfaction. All these 3 MUX by Px lines, that is MUX by Px1, MUX by Px2 and MUX by Px3, will be parallel to each other. We get the quantities consumed at different prices by equating these lines, MUX by Px line with marginal utility line, which is horizontal straight line. We are assuming MUM is not changing, MUM is constant. Marginal utility of money is constant, even though the price of the commodity is changing, is falling. Marginal utility of money for the consumer remains constant. That is the reason this is a horizontal straight line parallel to x-axis. Now, in the bottom part of this diagram, we have drawn the demand curve, which is derived from this figure, from the upper part of the figure. OP1 is the quantity demanded or quantity consumed by the consumer at Px1 price. So here we have plotted OQ1 and Px1. We have got point A. OQ2 is demanded or consumed by the consumer when price is Px2, that is, price has fallen from Px1 to Px2. We have plotted OQ2 and OP2. We have got point B. And with further fall in price of X from Px2 to Px3, the consumer is consuming OQ3 units of the commodity. Again, we have plotted OQ3 and Px3, and we have got point C. Now the line joining these 3 points ABC is the demand curve as denoted by DD dash. Correct? Yeah. So we have drawn the downward sloping demand curve dt dash, which is the normal shape of demand curve for all the normal commodities. Certainly there are exceptions to the law of demand, that is price and quantity are inversely related, that is when price of a commodity falls, quantity demanded increases, and when price of a commodity increases, quantity demanded falls. This is the law of demand, but the law has certain exceptions which I shall discuss in some other video, where the theory of demands, other chapters will be discussed. Yeah. So this is enough for this video. Yeah, this is enough for this video. Hope you have enjoyed this video. Please do like our channel. Please do subscribe our channel. Please do send your comments, your queries, your suggestions. Okay, those will enrich us. Okay, and thank you for watching this video. Goodbye and stay well.